Start record. And let's go through.
Because
What?
isn't
What?
it using integration by part?
No.
No.
Let me see. What have I went through already? Let me double check again. I only went through one part for. Oh, I didn't go through absolute value. Okay, we take a look now. So for integration of absolute value function, you need to understand what's an absolute value function first. So modulus x equals to two pieces, x or minus x. Why do we have that? Because how do you draw the mod x function? First, you start with y equals to x. Then you take the parts that are below, you reflect it on top. So what do you end up with? You end up with the following. Sorry, I didn't label my x and y axis. You end up with the original y equal to x, but the part that was below gets reflected on top. So it becomes symmetrical like this. Do you see the two pieces of pink and blue?
Okay.
The blue equation is y equal to x. The pink equation is y equals negative x. That's what absolute value or modulus function does. It takes negative values and makes it positive by multiplying -1, which is graphically represented by reflecting the parts below x-axis above. This part of the graph has many points. The y coordinates are negative. Like for example, if this is x equal -2, the corresponding y value equals to -2. Absolute value of x, where the function is y equal to x, means absolute value negative, x equal to -2. Then this will give you +2. So essentially what it does is it reflects it on top. Instead of -2, -2, it turns into x stay the same, but the y times -1, so +2. So you get a point here, -2 or +2. Of course, you just repeat this for every single point, you end up with a reflection. So more importantly, there are two functions, -x, x. Let me use the same color coding. I'll use blue for the x, then pink for the -x. But if you notice the x, right, it's starting from where? Does it
From
start
zero.
from -x? No, it starts from 0, right? So that's why you say x more than 0. How about the pink one? It's x less than 0. How about the middle case? There are only 3 types of numbers in the world for real numbers. Negative, positive, and or
Ne
yeah.
Wait,
X less than
what
0 is negative values. Negative. X more than 0 is positive. What's the third type of number missing?
Like equals 0.
Equal to 0. So that means that in order to fully define my what I call a function, I have to put in an equal sign somewhere. You put it either at the top or at the bottom. Just choose one. Oh, doesn't matter because when x equal to 0, positive x is 0. Negative x, -0 is also 0. Okay? This is important, the domain of a function. You must cover all the x values if possible. All right, so that means that if we look at the function now, we got integral from what to what? Integral of the modulus x dx from x equal -1 to +1. So when x equal -1 to +1, this is x-axis, it means -1 to +1. It also means we want to find the area of this curve. Okay, can I just get rid of this -2, 2? It's blocking my space. Just now delete it. What it really means is we're trying to find the area from x equal -1 to x equal +1. What is the area of this piece on the left plus the piece on the right? Can you see that?
Okay.
All right. But there's a sharp point. Oh no, sharp point. Oh no, sharp point. So how to integrate? We cannot integrate absolute value functions. We have to open up the definition, positive and negative, and then we split it into the two separate pieces. So let's think about it. Sometimes it is -x, sometimes it is positive x. We just discovered that it will be -x from for what values of x?
Less than 0.
So if you look at this x values, the limits tells you the x values we're interested in. X equal -1, x equal -0.9, -0.8, 0.3, 0.2, 0.1, 0, then positive 0.1, positive 0.2, blah, 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 0.8, 0.9, and then 1. Right? All these values here. So when is x negative? Isn't it just from x equal -1 to just before 0? Then in this case,
Yeah.
from -1 until 0, what is the function? Is it
Negative x.
Very good. It's still absolute value x actually, but
Oh.
we can simplify it down into what you said exactly. Yes, it's negative x now. Plus integral from 0 to 1 of positive x dx.
X.
Right, then this one need to go through now. Don't need lah. You know how to integrate. Okay, just finish. I'll just finish going through. Okay, then x integrate, you get x squared over 2 square bracket -1 0 equals to, I need to sub in later. So -0 square over 2. I should put up. Okay, very messy. Can I just factor out this negative sign? And then I'll have the negative sign here over again. So 0 square over 2 minus away -1 square over 2. Plus, okay, don't do 2 lines at a time, that'll be confusing. Integrate x square over 2, square bracket, lower limit, upper limit. Sub in, then you end up with 1 square over 2 minus 0 square over 2. Type in the calculator and you get your answer. But of course, you can do it manually too. This is minus outside. This is plus, let's see, half, minus 0, and minus 0 can disappear. Becomes positive half, plus a half, which is what? 10? Yeah, extension question. What if I want you to find, let's say, I come up with something more evil? Let me think a bit. How about modulus of cosine x? Let me think a bit. From 0 to pi.
Okay.
Step 1, draw or sketch the curve. The integrand. Integrand is the thing inside. So how does it look? And we restricted the x value from 0 to pi.
Okay.
Cosine, do you draw already? Good. Okay, but 0 to pi, so that means we only need 2 pieces until here. Okay?
But I mean, yeah. Then I mean, cos absolute value. Then they're like this.
Very good. Draw the modulus version. Draw the modulus of that function instead. So that means you just reflect it on top. So I'll just do it step by step. Copy, but to reflect the bottom piece. Maybe I will use my different color. Circle, go up. So you end up with this curve instead. Okay, good. Then you need to find integral from 0 to pi. So it's really just finding the area from here until there. What's the in-between x value?
The in-between value or cosine 90. I mean cosine pi over 2.
Oh, that's the y coordinate. This is just pi over 2. Okay?
Okay.
Then after that, continue. So this is pi. What do you want? You want to integrate this into 2 pieces. So here you must understand cosine x modulus, in this case from 0 to pi, we're gonna split it into 2 different, this is what I call a piecewise function. 2 different functions. What do you think they are?
What cosine x and then negative cosine x.
Good. So you will stay as cosine x when it's positive. When is the graph positive?
From 0 less than pi over 2 more than 0.
Okay, good. I guess we can have equality also. Just equal sign for both. Then negative?
Less than pi more than pi over 2.
Yeah, okay, good. Here I purposely put strictly less than to make it not overlap with the previous case. Imagine you're a computer. You give it instructions. I say x equals to pi over 2. Dear computer machine, can you give me the answer what is modulus of cosine pi over 2? Then he will read the input, the computer, it will replace into the x, and then it will look at the instruction, but it will follow the instructions here. The instruction says, if x is in between 0 to pi over 2, including pi over 2, use cosine x. Substitute the x inside this one. But over there, if you also put an equal sign, then the computer will get confused. How come got another instruction here also says that when x is pi over 2, use me instead. So now you have two different functions to use, right? So it's a bit confusing. So that's why you have to be a bit more precise when you're writing the domain. Don't only include equal for one of them. This one is about domains. I didn't have time to talk. Yes, and then you just split it up into these two pieces. Correct. I don't need to talk so much. Okay, you get it already. So you just gotta just copy down whatever you wrote. 0 to pi over 2 modulus cosine x dx plus integral pi over 2 until 1 modulus cosine x dx. But from 0 to pi over 2, modulus cosine x is just cosine x plus integral pi over 2 to 1, it's negative cosine x dx. This one, don't need to go through. Integrate cosine, you get sine, sub in pi over 2, sub in 0, and minus in between. Just fill in the blank. Okay, moving on. Next, it's just x cubed, right? So it's the exact same thing, the same procedure. Maybe I write down some procedures first. This is step 1, draw the curve and draw the absolute value function. Step 2 is you must split the integral up into the two pieces such that in one interval of values of x, the graph is entirely positive. In another interval, it's entirely negative, and then you just times -1 to make it positive. Okay, let me give an extension. What if I want to integrate from 0 to 2 pi of modulus sine x? Maybe I should say split at the sharp points. Just now there was a sharp point. Let's say we want this instead. So this time let me just go through the whole procedure. Sine x, I draw the curve up, down, up. I realize it's 2 pi here. In between it's pi over 2, 3 pi over 2. I'm not gonna label pi over 2 and 3 pi over 2. Very messy. Then after that, I draw the modulus version, reflect. So the bottom piece goes up. McDonald. M. Right. Then here you have 0 to 2 pi. So what does it mean? Split, right? Split. So integral from 0 to pi, this piece will be, if I just give a step, it's sine x. Other pieces?
Negative sine x.
Good. Okay, you got it already. Now let's try another example. Let's say that I use cosine x this time, but 0 to 2 pi. Modulus cosine x. So same procedure again. First, sketch cosine, down, up, until 2 pi. Then the absolute value version. Here you have to be careful. It's down, then up, down, and up. Because the bottom piece over here, the bottom piece over here, it goes up. Let me just highlight it. Okay, then you have to think carefully what are the x coordinates at the sharp points. You see this one very pointy, right? This one very pointy, right? What's the x coordinates? Pi over 2, 3, pi over 2. Okay?
Okay.
Good. Then how do you find the area now? You have to split into 3 pieces. Because of the sharp points are a bit different, you must go from 0 to pi over 2 mod cosine x dx plus integral from pi over 2 to 3 pi over 2 mod cosine x dx plus integral of 3 pi over 2 until 2 pi Not cosine x dx. Okay, then finally you must think, modulus cosine x from 0 to pi over 2, is it positive or negative?
Okay.
Positive, so it stays the same. Then the middle piece, how about
Negative.
how about the right piece?
Positive.
Good, you got it. So you can imagine the absolute value can apply to any kind of function. It just gets more and more complicated. The same procedure follows. Step 1, step 2. Step 1, draw the curve. Step 2, draw the modulus version, reflect the bottom to the top. Step 3 is to okay, and step 2 actually I also need to mention you must label the x coordinates that are at the starting and ending points as well as the sharp points. Then step 2 is just to split the integral up. Split. Okay, then once you have each piece, you must find out if it's using the positive version or the negative version of the function. In this case, the middle is the negative one because it's the one that got reflected. All right.
Mhm.
And yeah. So moving on. Wait, I already screenshot the question. Let me scroll up. Let's see. For x cube, x cube. This one should be okay, right?
Wait, what? Isn't it
wanna try?
isn't it the same thing?
Yeah, it's the same thing.
Okay. Yeah, and now okay.
Yeah. Try yourself. I'll just draw the x cube curve for you. It looks like this. Then you reflect this piece on top. Okay. Moving on. Part 3, 2x sine 1 minus x squared.
Yeah, okay, how?
So 2x. Wait, what do you mean how? Which question?
The one you just said.
This one, yes. So this you need to see that there is the composite function. Let me ask you, if you differentiate sine. No. If you differentiate 1 minus x squared, what do you get?
Isn't this in the formula list?
Whoa. Huh? 1 minus x squared need formula? No, I remember already. Differentiate, not integrate. The forward direction.
What?
Differentiation. Can you tell me what's the derivative of 1 minus x squared?
I mean, two negative 2x.
Yeah, that's correct. Differentiate 1 gets 0, differentiate negative x squared is negative 2x. Okay, good. Then here you have a 2x. So I'm going to do is I'm going to multiply both sides by -1. So minus negative 2x times of the sine 1 minus x squared. So then you need to know that this is actually this is the form where you have an outer function here. Outer. Then there is I'll use pink color, inner function here. And then you have a third piece, which is
D inner.
the derivative of the inner. Once you have this form, all you need to do is to copy down everything else that tag along. Integrate the outer function, All you have to do is to integrate the outer function, sine, so you end up with a negative cosine. Then you just copy down the 1 minus x squared. And that is your answer. The d inner minus 2x just disappears. How do you verify that I integrated correctly?
Differentiate.
Yes, so you differentiate the answer. Let's see what happens. When you try to differentiate the cosine, 1 minus x squared, definitely you need to use chain rule. Differentiate cosine, you get negative sine. Keep the inner function. But don't stop there. You must multiply by derivative of the inner function. So it's negative 2x. Yes, and then you get back the original. Okay? So the idea is simply to fit it into this form so that you can work backwards. The minus 2x disappears. Chain rule will introduce the extra negative 2x times. So that's why when we work backwards, it disappears. When we work backwards, the negative 2x disappears. Okay, moving on. Let's see. How about part 4? I went through already. Right? How then part 5? What's the derivative of secant x? Have you taken a look at the MF26?
The derivative of what?
Secant x. I mean, you can derive it
Secant
yourself.
x.
I'll show you one time. Differentiate secant x means differentiate cosine x power -1.
Is secant x tangent x.
Yes, it's secant x tangent x. Okay. Son, do you need me to show you?
Mm,
I-
wait, so
Okay, so I think don't need for now, because we are focusing on integration. We'll focus on this guy. So it's secant x tangent x. So what? So what we have
so
is
you have the inner,
mm-hmm,
you have outer, and then you have inner.
correct.
And
So
then
it's
the
already in the
inner.
correct format. So therefore,
So you say just integrate the outer, but
which is
that's
e power
just
x,
yeah,
which is just e
that's just e
power of. We must keep the inner.
secant x.
That's it. Done. Fussy. One line only. There's no working. You just need to recognize it's in the correct format already.
Well, this is very like not intuitive, but okay.
Yeah. So it takes some time to get used to it. Okay. How do you check that your integral is correct?
Differentiate
Differentiate.
e secant x.
Okay, do it now. Differentiate e, you
So
get back the same thing.
get back d secant x. Then you must
Differentiate the
differentiate the the inner.
inner function.
So yeah, okay, yeah,
Okay,
that's correct.
so it's the same. So once you recognize it, it's like there's only one line, there's no working. You just need to spot the pattern. Oh, okay, good. Question 2, I went through already, right? Did I not? Okay, question 2, part 1, I think I went through. Right? So this one is in the ultimate summary. Let me find my summary. Where did I put it? Integration. No. I need to update the cheat sheet already, the integration one, because I realized I left out some parts. Oops. One second. There we go. Double check something. Where you're right. It's here. Part B, integration of products or modular functions over here. So what you need to see is that it's actually the same thing, do you see, as the outer function, inner function thing. This is your inner. Maybe I label fx is your inner. This bracket power n is your outer function. X power n is outer function. Then at the front end, you have the inner, the derivative of the inner function. Can you see the same pattern?
Okay.
It's just that I changed the outer function to power n. Then that means that all you need to do is to integrate the outer function. Integrate our power n means you get power n plus 1 divided by n plus 1. But you keep the inner function. Plus c. This is called the inverse chain rule, reverse chain rule. Because it's literally just working backwards from chain rule when you differentiate.
Okay.
Oh, okay. Let's see how to apply it. I mean, I explained it last lesson with the 3 part 1 already. So just a recap. what's going on. Here, this guy you can rewrite as 3x squared multiplied by 1 over square root 1 plus x cubed dx, right? But you need to know your exponents very well. Square root means power half.
Square root means power half.
Right?
Okay.
Then you bring up, you flatten the fraction so that it becomes 1 plus x cubed as the base with brackets. But positive half, if you bring up, what do you get? When you switch
Negative
sides,
half.
negative half. So if you compare with the formula, what you realize is that the n is negative half. Okay, maybe I just copy this over. You see? Can you see the pattern?
Mm-hmm.
F prime x here,
This
fx is
is
in between the
inner.
brackets.
And it's D, then this is outer.
Very good. So all you need to do is to copy down the fx, square bracket around it. Fx is 1 plus x cubed, the inner function, square bracket around it to the power of n plus 1, minus
N
half
plus
plus 1.
1, so half.
Correct. Simplify to positive half.
Oh.
Then divide by positive half. Plus c. Can
Okay.
you differentiate, you'll get back the same thing. I went through last week already. Okay,
Yeah.
I'll upload the video soon. I'll give you some time. Okay. Anyways, now I deal with that part 2. So part 2 is I just scroll down first. Can I take a screenshot? Oh yeah, I forgot to take a screenshot. 1 second. I need to take a screenshot of this. Okay, so question 2, part 2, we have cosine x on top, then square root sine x minus 1. Usually the culprit is always square root. When you see square root, you will need to involve this method. So let's take a look. What's the trick? Rewrite this square root sine x minus 1 as multiply by cosine x multiply by
1 over sine x minus 1 to the power of half.
right.
And then you bring it up, so then it becomes it becomes sine x minus 1 to the power of negative half, because you flip it.
Good.
Then this is your outer, this is your inner, and this is your D inner.
Yeah, because differentiate sine x minus 1, you get cosine x minus 0, which is just cosine x. Good. We have the correct form.
You copy the fx, which is sine x minus 1, to the power of half, then divide by half, then plus c.
Okay, let's verify if this is correct by differentiating it. Okay, so let's see. Differentiate this expression. I won't copy the c because differentiate c just gets 0. Okay, over 1/2, can I just clean up a bit? It becomes times 2.
2.
Right?
Yeah.
So I can differentiate by factoring out the 2 and make it look a bit neater. Then very messy. Yeah. Equals to 2. Then you multiply by, bring down the whole power half. Copy the base sine x minus 1. Minus 1 to get the due negative half. Times, don't forget the inner function you need to differentiate. So you get cosine x minus 0. So of course that's just cosine x, and you see that it's the same. Okay, clean up a bit more. 2 and 2 cancel away, you're left with cosine x times sine x minus 1 power negative half times cosine x, but multiplication you can swap the order around, it's commutative. Left times right and right times left, like juggling balls, you can swap the order. Left times the right, right times the left. Same thing. And then you realize it's the same. Because power negative half, you can always bring down.
Yeah, bring down, then becomes square root sine x.
Yes. Can okay, good. So definitely correct. How about part 3? So far we've been seeing something at the top, then divide by square root of something else, then you bring up switch sides, right? So how about this part 3? Should you do the same thing?
Isn't e2x square root equal to e2x and half? Then it's just e minus x. Wait, am I
Right.
tripping?
Yes, this was a trick question. I always put it at the end. After you see the same format, something on top, then divide by square root something, some students will just think, oh, I must always switch sides, change to negative half, switch sides, change to negative half, but that will actually make your life more difficult. So yes, you should just immediately see that you can simplify this down into a negative x because of what you said. Right, because square root is just power half, and we already have a power as the base, so we can just multiply the powers. Negative 2 times 2, 2's cancel away, left with negative x. And then you can even simplify this a bit more, because e power something over e power something, you just subtract, right? So it's e power 5x minus way negative x. Which is e power 6x. You try to integrate that, what do you get? Same thing, divide by 6 plus e. Okay. Okay, next.
So the last one is not
Not the
not
same form. Yeah, it's a trick question.
okay.
Okay, question 3. Now this one is we come from A level. Okay, let's take a look at the question. So you have a fx equal 3 plus cosine 5x. Part 1, you want to find the integral of fx dx. So that's just saying replace the fx with 3 plus cosine 5x. Okay? So integrate 3, what do you get? 3x. Integrate cosine, what do you get?
You get wait. You get sine.
Yes. Maybe you need a recap. Quick recap. If sine x, you differentiate already, you get cosine x.
Cosine.
Cosine x, you differentiate already, you get negative sine
Negative.
x. Now work backwards. So it has to be sine of 5x, but you must got 5 in front of the x.
Times 5.
Hmm.
Wait. Divide by 5.
Integration is the reverse of differentiation. Differentiation requires you to use chain rule. There's an inner function. Differentiation will need you to times 5. But we are not doing differentiation. We are doing integration. Integration is the reverse of differentiation. So we do the opposite of times 5, which is divide by 5. Do the reverse process. Opposite of times 5 is divide by 5. Okay, then plus C. Easy, part 2. Find the exact value in terms of pi of integral from 0 to 0.5 pi, that's half a pi over 2, of x times fx dx. What's x times fx?
Mm-hmm.
We have to work it out. Let's work it out at the side. It's easier. So my fx is 3 plus cosine 5x. Then you have x times fx means what? X times fx means x times this guy. You see that?
Mm-hmm.
Yes, so the x can distribute into each of them. You're left with 3x plus x times cosine 5x. Okay?
Okay.
So that means that this integral is really just 0 to 0.5 pi of 3x plus x cosine 5x. Then? Yes?
Yeah, okay.
Then integrate term by term. Okay, so we're gonna do that. So integrate 3x, you get 3x squared over 2 plus integrate this guy. Problem. Okay, maybe I shouldn't have.
Is this integration by part?
Yes, correct. How do you recognize unit integration by parts?
Something times something. Wait, is it? I
Correct.
don't know.
Yes, when there's a product. Okay, let me just make it look more symmetrical. Integral, you split first. Then after that, this piece you integrate. And this piece, question mark, question mark. You must do it as a separate question now. So what's the procedure for integration by parts? Set up your table first. Set up your table first. U here, V prime here. U prime here, U here. Prime is just a lazy way of writing dv by dx. I'm just gonna, and U prime is du by dx. I'm just gonna be lazy and use the simpler notation. Use a prime. Okay. Our meeting is gonna end in 3 minutes. So let me just continue talking. Tell me to quit and join back in later.
Okay.
Okay, so your the question is, okay, the procedure is you must always select your U and V prime. Notice how you need to differentiate U and integrate V prime over here. Oops, I made a mistake here. This should be a V. Integrate here, differentiate here. So which one do you think you want to select as the U and the V prime?
Teams D, or I don't know. What other one?
LIATE, liate.
LIATE.
What's so special? What's L? L is logarithm. Can you integrate logarithm easily?
No.
Integral ln x? Cannot.
No.
Integrate 1 over x gives you ln x. Differentiate ln x gives you 1 over x, but you try to integrate ln x, don't have. Let me write this down to remind you. Ln x, differentiate, becomes 1 over x. Differentiate, this one is just x power -1, so it's negative 1 over 2x. Okay. Squared. No, that's not 2. What am I saying? Negative 1 over x squared. Right, x power -1. Bring down O power -1 to get the new. Right? Then how about integration? Yes, we can just integrate to go backwards. But how about if you want to integrate ln x? This requires, I already showed you last week, it's integration by parts. So that's so basically you need to quickly remember that ln x you try to integrate cannot, too difficult. So that's why we put down this mnemonic. The one that has L on the leftmost means that you want to select L as the one to be differentiated. In other words, L on the as the U, so you can differentiate it. So how to use the mnemonic? The guys that are closer to the left, you're gonna select as U. The guy closer to the right, we're gonna select as V prime. Why? Because the ones closer to the left is difficult to integrate. We want to differentiate it instead. The ones that are on the right side is easy to integrate. You look E exponential, how to integrate? Get back the same thing. Divide by the coefficient of x. And then you just get a V. So it's easy to integrate, that's why you select as V prime. So here, yes, very good. We have A and T.
Wait, what? Okay, logarithm.
Right, x is algebraic, then cosine phi x is trigo. So who's on the closer to the left? A is closer to the left. That's why you select it as x.
What's E? Exponent.
Exponential. Oh, you forget what it stands for already.
What's I?
Let me just show the cheat sheet so I don't have to rewrite it. Logarithmic, inverse trigo functions, algebraic, trigo functions, exponential. Yeah, there we go. Okay. Ln x, sine inverse, cosine inverse, tangent inverse. Algebraic is x squared, x plus 2 cubed, for example. Then trigo is sine x, cosine 2x, or could be secant x as well. Then exponential is just e power. Okay. By the way, this is a rule of thumb. It only works around 80% of the time. The more difficult, interesting questions are this LIATE mnemonic doesn't work. And your only answer to how do I select what is my U and V prime, it's guess and check. Guess and check is the only way. The goal is to ultimately break it down into another integral that is easier to integrate or possible to integrate.